Hi everybody, in this video we're talking about intersections of lines and circles. We're basically deciding whether lines and circles are going to meet and what that could look like. Now, there's three possibilities to consider and we've got them as diagrams down below. So what could happen is the line and the circle could overlap like this, and there would be two distinct solutions, so two different answers there. The other thing that could happen, we could just have the line touching the circle, effectively acting as a tangent, and there'd be just a single answer. Another thing that could happen is the line and the circle could miss each other completely and there wouldn't be any solutions at all. Okay. Now, even though this idea is new within circles, the processes that we're going to use aren't going to be new. You've encountered them before. Think about where you might have seen this before as well, having 2 or 1 or 0 solutions. You think about quadratic equations. Quadratic equations can have 2 solutions, or 1 solution if it just touches the axes, or 0 solutions if it misses it completely. And those rely on the discriminant, okay, being positive or 0 or negative. Okay, so there's an analog here. We can use the discriminant for all of these. I'm going to write those in quick. There we go. Okay, so basically what we're going to do, we're going to try and solve these equations simultaneously, the circle and the line together. We're going to sort of combine those equations. Most of the time we'll encounter a quadratic when we do that. We'll solve that quadratic equation and we'll get our answers. Let's have a look at an example. The first one that we have here is the line y equals x minus 2 and the circle x squared plus y squared. Take away 2x minus 4y minus 4 is 0. So a bit hard to tell what the radius and what the center is just based on this, but doesn't seem like that information is particularly important for this example. I have drawn it out here on GeoGebra. Here's the circle, typed it in already over here, and here's the line, x minus 2. The line's in black, the circle is in blue. I can see that there are 2 crossings here. Let's put them as values. So I've got 2 coordinates, 4, 2, and 1 minus 1. Hopefully that's what I'll end up with. If you're feeling confident and you want to pause the video and try and work ahead, this is what we should get. If you're not sure where to start, just bear with me for a little bit longer. Now, this equation, y equals x minus 2, what I'm going to do is I'm going to replace all of the y's in the circle formula with x minus 2. So this is going to replace the y here and the y there. And when that happens, I'm going to end up with an equation with only x's in it. And it will be a quadratic equation since I've got x squareds, but I can solve that quadratic equation. That'll be fine. Let's write the circle out one more time, but let's change the y into x take away 2. This is the y squared bit there. The 2x is going to stay as it is. The minus 4y changes into 4 lots of x minus 2. And the minus 4 and the 0 are going to stay the same. All right, nice, cool. All right, let's tidy this up then. So I'm going to need to FOIL this out. So I'll write down x minus 2 squared effectively over here. What I get, x squared minus 2x minus another 2x plus 4. It's going to work out as x squared minus 4x plus 4. I'll just emphasize that bit there. This has changed into this. Okay, and I'm going to need to be careful here Expand this bracket. Minus 4 times x, that's just minus 4x, that's fine. This is the part that I need to be watchful of. Minus 4 times minus 2 is plus 8. So it's easy to miss that sort of thing, and that will mess us up later on if we don't include it. So we want to make sure we've got that one there. Okay, here's our tidied up quadratic. Let's tidy it up a bit more. So I've got 2x squareds. These here. How many x's have I got? I've got minus 4. Take away another 2, take away another 4 again. So that's 4, 2, and 4. That's minus 10x. And what about the constant component? I've got plus 4 here. I've got plus 8 there, and I've got take away 4. The minus and plus 4 cancel out. I end up with plus 8. Go. Okay, cool. So here's my quadratic equation. Since I'm solving it, I'm going to divide it by 2 to make the values a little bit more manageable. I'll get the quadratic x squared, take away 5x plus 4 equals 0. And that looks quite nice. I think that will factorize. So that's what I'm going to try and do next. I'll try and factorize and solve it. And two numbers that multiply to make plus 4 and add to get minus 5. I think I can choose minus 4 and minus 1. Do that. Yes, I can. Fantastic. There's two solutions, which are either x minus 4 is 0, which means x is 4, or x is 1. Cool. So I've managed to get the x values out. So I have a look here. You can see that there's a crossing when x is 4 and another crossing when x is 1. I don't have the y values though. So I'm going to need to work those out too. And to get the y values, I just go back to the beginning. I have a look at where I started. And I'm going to sub that back into my original equation. So it's kind of like the process when you do simultaneous equations. Well, any simultaneous equations really. You just go back to the initial equations and find the corresponding y value. Let's sub this in to y equals x minus 2. The y value is going to be, in the case of x is 4, 4 minus 2, 2. And in the case that x is 1, it's going to be minus 1. So this bit here, this corresponds to a coordinate of 4, 2. And this one over here, the x value is 1, the y value is minus 1. We get another coordinate out from that 1, 1. And we can see that here. 1 minus 1, 4, 2. Yeah, nice, good stuff. All right, there's another example here. And it's worded a bit differently, actually. It says that we want to show that it's a tangent. Slightly different wording. We're going to proceed initially just the same as we did before. We're going to plug the line equation into the circle equation. We're going to replace any instance of y with this formula here, x minus 3. Right, so that's how we're always going to proceed. Let's start by doing that. And I'll be a bit quicker through the tidying up parts here. And I'll feed to the foiling bit. Careful with the minus minus here. Divide by 2 once again. Okay, and I've got my quadratic equation. Now, once again, this one I can factorize it. And it does actually factorize to x minus 3 twice. And at this point, in some sense, I am done here. I can see already that there's only going to be one answer. The wording of the question just said, show that it's a tangent. It didn't say, find the point of intersection. I could still do that. I can plug x is 3 into this equation. 3 take away 3 is 0. So I can do that. And I've only got one answer. The other thing I could do is I could take that equation here and I could run the discriminant on it. And I could see what I get. So b is minus 6, a is 1, c is 9. There we go. So another way of approaching it is say, I'm going to work with the discriminant. If the discriminant is 0, there's only one answer. And if there's only one answer, the situation is going to be one of these. Single answer. Just touches the circle once, therefore it's a tangent line. Okay, so whatever way you do it, it's up to you. But this, what I've written in blue here, it's, I guess in some senses it's easier because you can always use that method. And it does give you the actual point of intersection. The stuff with the discriminant, it might be quicker, but it doesn't actually tell you what the answer is. So yeah, swings and roundabouts, depends on the wording of the question.